In today's video, I'm going to go through some of the recent 2025 paper questions that were high marks, like 5 marks or more. There are one or two that aren't 5, but they are still tricky, so I decided to add them as well. So let's take a look. Oh, by the way, you can download this in the description and try it on your own. As I always say, it's better to try and get stuck on your own and then watch the video afterwards if you get stuck. Anyway. So this one here, they're telling us there are 3 polygons and A, B, and C, and they meet at a point, and the interior angles are in a ratio of 3 to 4 to 5. So I'll write that down, 3 to 4 to 5. And because, let's just carry on and see what we have to do. Show that polygon C is twice the number of sides as polygon B. Sorry about that. Okay, so ratio question, we'll just add these up first. So 3 plus 4 plus, not plus, that should be a plus 5, that would equal to 12. And I know there are 360 degrees all the way around, so it'll be 360 divided by 12, and that 12 goes into 36 3 times, and then the 0 is left. So 30 degrees. So this ratio of, let's make it A to B to C, it's going to be 30 times 3, which is 90, and 30 times 4, which is 120, and 30 times 5, which would be 150. So that's just telling me that the angle size is 120 for B and 150 to C, but it doesn't tell me the number of sides. And to get the number of sides, I need a formula. There's a long and a short way. I'll quickly show the long way. So the 150 n minus 2 kind of formula, that would be the total of all the interior angles, but I want just one. So I'll divide by the amount of angles. And in this case for B, it's going to be 120. And then this is a rearranging of formula. So then I would multiply by n and distribute. So I'd have 180n minus 360, kind of doing two things in one go, is going to be on multiplying by that n to have 120n, and you can rearrange this to be 180n minus 120n. Do I have space there? Yeah, 360. So I'll have 60n is 360, so n would just be 360 divided by 60 would be 6. So I know the amount of sides, this is a square obviously, so this is going to be 4 sides. That one has 6 sides, and I just have to figure out this one. The shorter or quicker way would just be to say, well, if the interior angle is 150, then the exterior angle would be 360. It would be 180 minus 150, which would be 30. And then I would just take 360 divided by 30. And 3 goes into 36 12 times. The zeros are kind of cancelling out. And then I would have 12 sides. And I would kind of just do a little arrow and say B times 2 is C. Just to kind of show, hey, look, I did show that this one has twice the amount of sides. So C has 12 and B has 6, so that makes sense. So going the exterior route is maybe a little bit quicker, but it's always good to know this formula for other types of questions. Okay, so 5 marks. That's quite a lot for not the most difficult question, but definitely a nice easy 5 marks. This one might not be as easy. Now there's probably a couple of different ways of doing this. I'll probably do this one on a separate video on its own as well, just because I like the question so much and it's been popping up a lot with these kind of segments taken out of circles. So the previous video, or there should be another video that I said, well, look, how do I work out just this segment there? And there's probably a good watch, but this is going to be very similar to that one. So in this one, they're saying there's a diagram showing a major segment of a circle, and the segment is a cross section of a tunnel, and the height is 3 meters, and the length of the tunnel, get the volume of the tunnel, 7 marks. That's quite intense. So let's kind of take this away, and then we'll kind of redraw this, because I think there are going to be some calculations in here that that we're going to have to do. So, okay, just want to get a nice, let's see if I can, no, I'm going out of the screen. Maybe I should just try and do a circle and then just cut a piece off. I think that's going to be the simplest way. Okay. What I know about this circle is, well, it's not a circle, but the height of this is 3 meters. And I know the radius is 2.5. That is given to me. So that's the start. And we want to work out basically the area of everything. There's a couple of ways. Let me do a kind of a diagram here to show what options we'll have. And then we'll take a look at what option I'm going to, sorry about that, what option I'm going to do. So first of all, we have that length. And because we have this length as being 3, then I know the radius is 2.5. So this will be 0.5. So I have that length. So I no matter what we're going to do, we're going to have to work out that angle. That angle is very important for us. And then we have a couple of options. Option number 1 would be, let's do, option A would be working out that sector, this sector, then subtracting the triangle, and then I'm left with this little segment. And then with the segment, I take the full circle minus the segment, and then that would be fine. Bit of a long route. Second option may be to say, okay, well, this is a semicircle, so I'll work out A. And then I can work out this as B, because this sector and this sector would be the same, because I'll have that angle if I have this angle. And then also this is the C part, this little triangle. So I can work out semicircle, sector, and a triangle area. These two will just be multiplied by 2. So that's the other option. But the option I'm going to go for is working out this whole part there. So if I have this angle, then I know this and this will be the same, and then subtract that from 360. So yeah, we're going to go to that route and then just have the area of the triangle. So let's take a look. Let's dive in. So no perfect right way. There's maybe just a shorter and a faster way. I'm going to redraw that little triangle, this triangle. No matter what I do, this is going to be the start, 0.5. I know that's 0.5 because the total height, that's going to be a radius, which is 2.5, and the total height is 3. So that's going to be 0.5. And I'm going to work out that angle. So that angle should be, this is adjacent. Now this, I'm going to use SOHCAHTOA. And hypotenuse, so basically the cosine of this angle is going to be 0.5 over 2.5. So this angle is going to be inverse of cosine. That's just 1 over 5, basically. But you'll just type that in your calculator, and then you'll get an answer like 78.463. So that is that angle. And now I'm going to times that angle with 2. I'm going to multiply this angle by 2 because I want, let me just write this. I want this whole angle there. Okay, so because I want the whole one, I'm just going to multiply this by 2. These are obviously congruent shapes. And that multiplied by 2 is just going to give me, I'll just say 78.463 times 2 is going to get, it should be, where's my calculator? It should be like 150 or something. Sorry. 78.463 times 2. And I'm getting this 156.926, etc. So what I do want is I want to now get this angle. So to get that, I'm going to take, let's just write it here, 360 minus the 156.926. That's the angle I want. But because I want the area of that whole sector, the major sector, I'm going to divide this by 360 and multiply this by the area, or the area of the circle, pi r squared, and the radius in this case is 2.5. So that's going to be that part. But then I have to add, so let's just work that part out first. If I type all of that in my calculator, then I should get a number like 11.057596. Okay, so that's just calculator work. You just type that in your calculator. But I want to, this was the segment part, but I want to add those two triangles. So in order to add those two triangles, I'm running out of space. I'm just going to wipe this out. So for the two triangles, easiest would probably be half times the one length times half the other length. So 2.5 times 2.5. This is just from the formula sheet that you would have. And then sine of that big angle over there, which we worked out as 156.926. So that whole angle there. And yeah, not really tricky, just kind of calculator work. And if you put that in your calculator, you get a number like 1.22605. We're going to add these two numbers together and we'll get 12.3021, basically just calculator work. And this would be the area of that part over there. And then to find the volume, we're going to take 12.30201 ... multiplied by the 800, because that's 800 meters that they said that the thing is wide. And we'll be left with an answer like 9841.6. And to three significant figures, or four significant figures, I guess. This three significant figures should be fine, but I would do just like this, just to make it nice and whole. And we have our units would be cubic meters. So yeah, I mean, there's a lot going on there. I think this would have been the quicker route, but there are other routes. But it all start with the angle of that circle. Well, not the angle of the circle, the angle of the triangle. Okay, moving on to the next one. What do we have? Let's see. Ooh, interesting one. Okay, so the diagram shows a solid A and a solid B, so we can see them there. The one is kind of a cone and a hemisphere stuck together, and the other one is a cylinder. They're saying solid A is made from a hemisphere and the cone. Okay, cool. Thank you very much. The radius is 6, and the cone has a sloping edge of 10. And then the solid B is a cylinder with a radius of 4 and a height of h. We don't know what the height is there, but they're saying the total surface area of the solid is equal to the total surface area of solid B. So let's take a look at this one. So this total surface area, let me just get the formula sheet here. So this will be given to you. We're seeing that the surface area of a sphere is 4 pi r squared, but we have a hemisphere, so we'll just divide that by 2. So it's going to be 2 pi r squared for the hemisphere part. And then for the curved area of the cone, it's going to be pi r times the slant length. So basically, we're going to have pi r slant length plus the 4 pi r squared divided by 2, which is just going to be 2 pi r squared. And that, they said, is equal to the surface area of the cylinder. So the cylinder has two circles, so it's 2 pi r squared. So pi r squared, well, those two are just kind of exactly the same. And then we have the curved area, which you should know is 2 pi r times height, but here it is, curved surface area of a cylinder, if you forgot, is just going to be 2 pi r times the height. Let's make a nice h there. Cool. So we want to find h. Now we know this equation is true. The one area is to the other area. First off the bat, I see this part and this part. They are the same. So I can basically just cancel them out. I can subtract that from both sides. doesn't really make any difference, because this and this should then definitely be equal to each other. And I don't want to work with pi, so I'll divide actually by pi on both sides. And then I would have r times L is equal to 2RH. The radius for this one is 6. And the slant height is 10. And here we have 2, and the radius in this one is 4. And then H. So here I have 60 as 8H. So 60, not 68, 60 divided by 8 is going to be H. Now this is probably, not probably, this was in a non-calculator paper, so maybe you can't do that immediately, but you can divide by, 4. So that would be 15 over 2 is H. And then you'll be like, okay, 15 over 2, that's just 7.5. So the height is 7.5. Pretty straightforward, quick question, but like a lot of marks. And then the next one is work out the height of solid A. So in solid A, if I drew my very beautiful sketch there, that is 6 and that is 10. And I know this is also going to be 6 because it's a hemisphere. So if I think about the total height, let's just make, you can't see on that side. Let me do this side. If I do a total height, I know that part to that part is going to be 6. This part I don't know, but I have a triangle here that is 6 something and 10. So basic Pythagoras should give this to me. I know that this height, x is going to be the square root of 100 minus 36. 10 squared minus 6 squared. So x is going to be the square root of 64, which is going to be 8. So that height is going to be 8. So 6 plus 8, if I use my fingers, don't forget your fingers in your IG exam, definitely need them to count. And then you would get to 14 centimeters. Cool, nice little question. For our next trick, we have a curved graph, a cubic function they're giving us. They're saying the diagram shows the graph of, let's just write this down, y is 3x minus x cubed. And the graph crosses the x-axis at point A, O, and B, so at 3 places. And the turning points are P and Q. Find the x-coordinate of A and the x-coordinate of B. So there and there, that's what we kind of have to find. And give your answers as exact values. So if I have exact values, I assume I'm going to have some kind of a surd in there. So this is also from a non-calculator paper. So if I wanted to find the x-axis or the x-intercept, then I have to make y 0. So I'll make y 0, 3x minus x cubed. And now I'm kind of stuck. But usually I know when I have curved graphs, if I have parabolas, then I try and factorize and get like an equation that I have factors on this side equal to 0. So in this case, I can factorize, can take an x out, and there would be a 3 minus x squared left. Now, here you might say, well, this is it's all factorized now. What do I do now? But because they said exact values, this is kind of the difference. This is a square number, but this is not a square number. But I should be able to handle it or complete. Like if I had something like this, if I had this, then I could factorize that to minus x and to plus x. But in this case, I don't have a square number here, so I'm going to do a little trick and do that. Because I know the square root of 3 times the square root of 3 is going to give me 3. So I kind of make it's not a square number, but I'm kind of doing the difference of squares. So now I have x and then this bracket and this bracket. So basically 1, 2, 3 things multiplied with each other, giving me 0. So it means either this x is 0, which makes sense because that's the origin over there. So this x being 0 is actually the origin. And then I can have the square root of 3 minus x is equal to 0. So x is going to be equal to the square root of 3, or x is going to be the negative the square root of 3. So basically, those are the two x values. So the x coordinate of A is a negative number, so A would be the negative square root of 3, and B, being this side of the origin, is going to be the square root of 3. So yeah, not high marks, but a little bit tricky seeing that this can go into that. Next bit, differentiate this. So dy over dx, very, very important skill for your exam. So we have, this is to the power of 1. 1 times 3 is 3. And then this becomes x to the power of 0, so we don't write it. And this is 3 times negative 1, so it's going to be negative 3 x squared. So that is that one. And then for the next bit, they're saying find the coordinates of P and Q. So P and Q, they told us they are turning points. So I know at the turning point, the gradient is going to be 0. So there I make this as a gradient function. So I make this 0 is equal to 3 minus 3x squared. And I want to solve this. Again, factorization would work. But first, I'm just going to divide by 3, make my life a little bit easier. So that's going to be 1 minus x squared, and I have the difference of squares again. So I have 1 minus x and 1 plus x. Kind of running out of space here, but x is going to be, in this case, 1, or x is going to be negative 1. I'm just going to kind of remove some of this. Don't need that. Everything now. Okay, so I have x is 1 and negative 1. So in that curve, I know the p for p and for q. The x value for p is going to be the negative 1 because it's obviously on that side of the origin. So that's going to be negative 1 something. And for q, it's going to be 1 something. And to get the something, I just have to put it back into my original function. The original function was y is 3x minus x cubed. If I put, let's go for p first. If I put negative in, it's going to be 3 times negative 1 minus negative 1 to the power of 3. This becomes negative 3. Any negative to the power of an uneven number will be negative. So this is going to stay negative 1, and then times the negative is going to be plus 1. So this is going to be minus 2. So for this, it's going to be minus 1 minus 2, which does make sense because it's below the y-axis, or below the x-axis, sorry. And for the other one, let's do it in a different color. Let's do it over here. Y is 3x minus x cubed. And then 3 times 1 minus 1 cubed. So that's just going to be 3, and this is going to be minus 1, so that's just going to be 2. So that's going to be 2, which makes sense as well because that's above the, well, x-axis again. Okay, so that was very, very cool. Very important is knowing what differentiation does and how to find turning points using that. I think I have 2 more left, so let's just do this one. This is in a non-calculator paper as well, so you're going to have to know your exact values for this one. The A part is not that tricky. It just says write down the value of cosine 90, so the cosine of 90 is just going to be 0, so no worries there, just a normal 0. But number B, let's say that was A, B is going to be the tricky part. So the diagram shows 2 different right-angled triangles, and they're joined by a common side. And we have they're asking write x in terms of n. Okay, so I'm going to do the first triangle, just kind of draw it here. Let's say this is the top triangle where that is x, and that's a 90 degree, and this is 30 degrees. And for the second triangle, I'll draw the second one there. Let's color code this so we know what's going on. This is the second triangle. This is also 30 degrees. And this length and this length is the same, but this is n. Okay, so since I have this x and I have that angle, if I want to get to n or from n to x, I'm going to go from the top kind of down. If I should be able to work out that length. And that this is, if this is my reference angle, this is adjacent, and that is the hypotenuse. So I am going to have to use cosine. So let's just go around saying the cosine of 30, not equal, or will be equal to x, a. So I'm just gonna leave that as an a, just call it a. And then I know this is adjacent, I'm just calling it a, but this a and this, so basically that length and this length is going to be the same thing. So I'm just kind of calling this a, although this is more a hypotenuse side, but I'm just giving it the name a. So there we have a over x. Now cosine 30, this is an exact value you should know, but if you were to forget, you know how to get it. So if we have a triangle, usually, okay, let's start at the beginning, quick. If we had a equilateral triangle that looked like an equilateral triangle, then all of these would be 2, and this would be 60, and that would be 60, and that would be 60, all those angles. But if we split this over, then these two would be the same. Then in this triangle, this is going to be 1, and in this triangle, this is going to be 30. And if I wanted to work out this length, it's going to be the square root of this minus the square root of this. So basically, it's going to be the root of 3 because it's 4 minus 1, square root 3. And now, working out the cosine of 30, cosine is adjacent, which is this one, over hypotenuse. So the cosine of 30 is going to be the square root of 3 over 2. And you can use the table method as well. That should be fine, but usually it's a bit easier to kind of just work it out with the triangles. You can maybe write that down in your test as soon as you get there. And then this is a over x, so that's fine. I'm going to write this as in this a. I'm going to make a the subject. And to do that, I'm just going to multiply with x on both sides. So then I'm going to be left with the square root of 3 times x, or x square root 3. Maybe that looks a bit better. Maybe I'll do that. X square root 3 over 2 is going to be a. So I know this a is this whole thing over there. And in this triangle, I'm going to look for, let's say I have this and this, which this is an opposite side, and that's a hypotenuse side. So basically, it's going to be the sine of 30 degrees is going to be opposite, which is my n, and that a, which is this whole thing that I got here, and it's not going to look pretty. So let me just make a very big long line there. This is n, and this is x square root 3 over 2. The sine of 30, you should know, is a half, but in our triangle here, I can see this is opposite and hypotenuse. So the sine of 30 is 1 over 2. So I have here 1 over 2 is equal to this over this whole ugly looking thing. And I can cross multiply. So basically, this times this is going to be this times this. So if I write that down, I know that x root 3 over 2 is going to be the same as 2n. I'm going to multiply by 2 to get that away. So I have x root 3 is going to be 4n. They're saying find x in terms of n. So I'm going to try and get x alone on one side. I'm going to divide by the root of 3. So I'm going to have 4n root of 3. But I don't really want to, I mean, that's the answer, but I don't want to leave anything in root form. So, well, with a root in the denominator. So I'm going to multiply top and bottom and just rationalize this. And then I'll be left with 4 times, so 4 root, well, 4n, let's just make it look nice. So this is going to be 4n times the root of 3 over 3. And that should be my final answer. So yeah, a little bit of a tricky. You could have gone from this one up if you wanted, but either or, that would have worked the same. Just very important that you know your exact values. Okay, and the last one, this isn't really high marks, but they are definitely a little bit tricky. So let's quickly finish this up. So I'll just read because it's very small to see. A is the point A12, so let's just write that. A is the point A12, and B is the point B27. And first part is pretty straightforward. They're saying find the midpoint for the y coordinate. Find the y coordinate of the midpoint. So they've given us the y coordinate. So to find the midpoint, that's just going to be 12 plus 27 divided by 2, which is going to be 19.5, I think. Just less than 40, because it's 39 divided by 2. So that should be straightforward. The second part, I think, is a little bit more tricky. Not insane, but a little bit more tricky. The line AB has a gradient of 3. Find an expression for A and, well, in terms of B. So if I think about gradients, I know I can use this y2 minus y1 over x2 minus x1. That would give me the gradient of a line. This y2 minus y1 I should be able to put in, so that's 27 minus 12. The x2 is, in this case, B, and the x1 is going to be A, is going to be, the gradient they told me is 3. So 27 minus 12 is 15. So if I wanted to get B and A alone, I'll just move this top over. So B minus A is going to be 15, because I got the 15 there, divided by 3. And 15 divided by 3 is going to be 5. And I want an expression for A in terms of B. So basically A should be the subject. If I move A over, it's positive A. And this B stays here, and this comes over, so it becomes negative 5. So A is B minus 5. So not too tricky, but still, I think it's still worth a video. And the B part. Okay, I'm definitely going to have to take everything away here. So they're telling me the point D. So let's make a point D. This is D. And this point is 2234. And E is the point 2339. So it's going to be a little bit forward and a little bit up. So that's going to be E. And that is going to be 23 and 39. Obviously not according to scale. And they're saying D is the point on CE such that 2CE is equal to 5DE. So there's a point, let's call it C, somewhere here, and 2CE, so 2CE as 5DE. I can rearrange this to make CE just kind of stand alone. So then I just divide by 2 on both sides. So I have 5 over 2 DE, or it can be written as 2.5 times DE, 2.5 times DE. So CE is 2.5 times DE. And they're asking me to find the coordinates here. Okay, so I think DE, I should be able to write that as a vector. So let's say DE as a vector. I should be able to do that because I know it's going from 22 to 23. So that's 1 positive in the x direction. And from 34 to 39, that's 5 in the y, and that's positive. So this is DE. So I can sub that in there. So I should have C is 2.5 times the vector 1, 5. So it's kind of a vector question. And CE would then be 2.5 times 1 is 2.5. And 2.5 times 5, that's times 4 is 20. Okay, so that should be 12.5. So now I know that CE is 2.5 and 12.5. So if I'm going from here to there, that's 2.5 plus 2.5 in that direction, and it's plus 12.5 to get to E. So to find E, I'm just going to go and say 23 minus 2.5, and that should be 20.5, right? So not 0.5, 20.5. And then the other one would be 39 minus the 12.5. And that's going to be 26.5. So the coordinates for, let's just put that, C's coordinates is going to be, the X is going to be 20.5. And the Y is going to be 26.5. Cool, that's that. I hope this video helped you, and good luck with your exams.